Hello there, my name is Emeterio, if you're curious of how to pronounce my name. However, I go by Rio, and this is my weekly summary told through a Screenomatic, sponsored by Screenomatic. So let's get started. So if you're curious to what we did this week, um, we actually went over three important things that I think we need to summarize, which are the new introduced circuit symbols, the analysis tools, and the first Arduino. And as you can see, I'm a procrastinator, so that's why most of my hours are spent Sunday and Monday. So let's go over the new circuit symbols and their meanings. Right now, there's 6 new circuit symbols. Well, some of them we are familiar with, but some we might need to review. A and B are independent sources, while C and D are independent sources. The A and C introduce current into the system, while B and D introduce voltage to the system. We are often unlikely to use these in class, however, it's good to know what their meaning is and how to use them. While E and F are all of these symbols that we are already familiar with. E is a single cell, and F is a battery, which actually is made up of cells that can range from 2 cells to, well, infinity. Well, not infinity, because there has to be a limit, but you get what I'm saying. Now let's go over the main focus this week, the analysis tools. The analysis tools are, well, tools we use to analyze a circuit or the components of a circuit. At the moment, we use them to analyze current, but I believe that we can actually work backwards to use them to measure other parts of the circuit if we are given the right stuff. In total, we learned 6 new analysis tools: Kirchhoff's current and voltage law, mesh analysis, node analysis, de Velen's theorem, and superposition and Norton analysis. I'm not going to go over them all in detail because that'll take too long and won't be a summary, but I'll just give the basics. To use Kirchhoff's current and voltage law to analyze a circuit, we actually take advantage of them and create a linear system of equations which we can input into a matrix to solve. Mesh analysis is actually where we create inner loops with inner current within a circuit and replace some variables so we can actually simplify an equation in order to get what we're looking for. Node analysis is where we take advantage of the nodes within a circuit and replace the current within a circuit with with variables in order to calculate the current. So we know that the voltage drop of this resistor is from V2 to V1, V1 to V2 over the resistance. So we can substitute that for a variable, and hence we're heads on. Now, the Velen's theorem is where we actually rewrite the circuit as a whole, creating a de Velen's voltage and a de Velen's resistance. However, for superposition and Norton, I'm still trying to get the hang of it, so I'm not really going to summarize it because I would be given the wrong information or inaccurate. All in all, analysis tools just give us new ways to approach a circuit, and I think this can be helpful later on, well, in the real world, because not everyone's going to do the same thing you are doing. They're going to think different, and they're going to use different tools. But by the end of the same, we're all going to get the same results done. Hopefully, the right results. And the last bit that we did this week is the first Arduino tests we did, where we constructed an Arduino with 3 LEDs. The purpose of this Arduino is so that when we are not pressing the button, the green light's on, and when we are pressing the button, there is an alternation of the red light to the green light. Of one red light to the other red light. The setup was pretty basic, and the easiest part of it, but the part that needs to be focused is the coding. So this part right here, from line 2 to 7, is an important setup to the code because it actually creates what we are reading and what we want to output based on what we put into the Arduino. So we know that the button is connected to the second pin mode, second one, while the LEDs are connected to the third, fourth, and fifth. Now, for line code 8 to 16, 8 to 6, well, actually 8 to 27, the rest of the code, we have a loop going on where it constantly reads what to do and what to output in the situation. If the button is not pressed according to the second resistor, to the second pin, when it's actually reading, the green LED would be always lit. However, if we were to press the button, the green LED would turn off and one of the red LEDs would turn on for a quarter of a second, represented in line 21. Then the red LED would turn off, but the other red LED would turn on for a quarter of a second. Which is pretty cool how we can just manage this from using code. And if you're curious to how to make the lights turn on longer, you can change the values and increase it, turning on for 2 seconds, 1 second, just as long as you write 1,000 or 2,000. The Arduino has a bunch of code that is essential to understand in order for it to function. And that's basically the weekly summary. If I were to say the main focus of this week would be the analysis tools. So I hope everyone has good luck on that. And this has been my weekly summary. Have a good day.